Alright, in this problem we have two rabbits racing in a tournament. One's a big rabbit and one's a small rabbit. We're told that the small rabbit travels 4 hops in the same time that it takes the big rabbit to travel 3 hops. And we're also told that the distance covered by the small rabbit in 7 hops is the same as the distance covered by the big rabbit in 5 hops. Okay? And the small rabbit travels 10 hops before the big rabbit starts. And the question is, how many hops must the big rabbit travel in order to catch the small rabbit? Alright, well this is a distance, rate, time problem. We know that distance is equal to rate times time, as long as the rate is constant. Okay, and that's what we're going to assume, that these rabbits, once they start hopping, they hop at a constant rate. Alright. So the problem is that the distances and the times are not given in what we would consider standard units. What we have is we're given a number of hops. Okay, so what I'm going to do in this problem is actually make the unit of measure the big hop, the length of a hop for the big rabbit. So I'm going to call it a big hop. I'm going to call it BH for big hop. And I know that 5 big hops is equal to 7 small hops. Okay? So, so I've got to convert the distance that the small rabbit travels in terms of big hops. Okay? Because I really would like to be consistent in the units that I use. So I know that a small hop is equal to 5/7 of a big hop. Okay? That makes sense? Alright, so when I'm doing this problem, I'm going to measure things in terms of hops. And my unit of measure is going to be the big hop. But I'll have to convert any small hops into big hops by this factor, 5/7, because a small hop is 5/7 of a big hop. Alright? So distance equals rate times time. We're also given we've given this information about the time it takes for the small rabbit to go 4 hops and the big rabbit to travel 3 hops. Okay, so let's rearrange this and we get that the time is equal to the distance over the rate. Okay, so I know the small rabbit travels 4 hops. Now that's 4 small hops. So we have to convert that to big hops. So 5/7, so times 5/7, that'll convert these small hops into big hops. Okay, and then so our distance that the small rabbit travels, it's 4 times 5/7 big hops. Okay, and the small rabbit's rate we'll just call RS. And the time, so this is time right here. This is distance over rate, so that's time. And the time it takes for the small rabbit to go 4 hops is the same as it takes for the big rabbit to go 3 hops. So 3 hops, and that's already in big hop units. So we don't have to convert that. And if we divide that by the big rabbit's rate, then that gives us the big rabbit's time. Okay, so now we have time equals time. So this is the time it takes the small rabbit to go 4 hops. This is the time it takes the big rabbit to go 3 hops. And they're equal, because we were told that. So I am going to convert the small rabbit's rate into the I'm gonna figure out the proportion of the small rabbit's rate to the big rabbit's rate. Okay, so I mean, essentially what I'm going to do here is if I multiply both sides by RS, and I can also multiply everything by RB and RB, so I get rid of that denominator essentially. So that'll give me that the big rabbit's rate is equal to, the big rabbit's rate times this 4 times 5/7, so I'm going to write that as 27, okay, is equal to, now here the big rabbit's rate cancels out, here the small rabbit's rate cancels out, so this is equal to 3 times the small rabbit's rate. Okay, so now if I divide both sides by 3, I get that the small rabbit's rate is equal to 20 over 21 times the big rabbit's rate. Okay, so now I have the small rabbit's rate in terms of the big rabbit's rate. And I'm converting everything in terms of the big rabbit, measuring everything against the big rabbit, because in the end I want to figure out how many hops the big rabbit has to travel to catch the small rabbit. So I want everything in terms of big hops. Okay, so I'm gonna okay, so I can use this now. So all right, let's look at the distance formula for the small rabbit. Okay, so the small rabbit starts out, takes 10 hops. All right, so the distance that the rabbit travels from the time that the big rabbit starts, he's already gone 10 hops, right? But remember, that's 10 small hops, so we have to convert that to big hops. So we take it times 5/7 plus the small rabbit's rate, right? That's RS, but I can actually write that as 20 over 21 RB. Okay, so that's the small rabbit's rate in terms of the big rabbit's rate. And if I take that times time, if I plug in any number for time into this equation, then I can get the position of the small rabbit at any given time. Okay, so we can also write a formula for the big rabbit. Okay, so we're assuming that the big rabbit is starting at time t equals 0. We're going to set that as the reference frame for the time. So the small rabbit has already gone 10 hops at that point. So the big rabbit's distance is just going to be the big rabbit's rate times the time. Okay. So now we have two equations, and so let's solve this. I know that the point at which the big rabbit catches up to the little rabbit, the small rabbit, their distances are going to be the same. Okay, so I want to find where their distances are the same. So I can just set these two equations equal to each other and solve. So I'm going to write this as 50/7 plus 20 over 21 RB times T is equal to RB times T. Okay, so let's figure out what we can move all of our unknowns to one side. This is essentially, we could write this as 21 over 21, because that's just 1 RB. If we subtract 20 over 21 from 21 over 21, we'll end up with 1 over 21 RBT. Okay, I'm just subtracting this 20 over 21 RBT from both sides. And that's equal to 50/7. So then I can just multiply everything by 21 and figure out what the rate times the time is. So so 21 times 50 over 7 is equal to the big rabbit's rate times the time. And this will be the point at which he catches the small rabbit, okay, because their distances are equal. So let's see, I can factor out a 7. So I end up getting that this is 150. And the big rabbit's rate times the time is actually distance. Right? Distance is equal to rate times time. And I have everything in terms of big hops. So this is big hops, okay? So this is the number of hops that the big rabbit takes. So hops of the big rabbit in order to catch up with the small rabbit. Okay? So there you go. That's kind of a tough one, and the toughest thing is just, yeah, we at least in the way I did it, I had to define what my units were, and then convert everything to that unit. And the unit that I used is kind of unconventional. It's the length of a big hop.